It's not exactly rocket science, but it's close. Welcome to the Macke Makerspace. Hi, I'm Brother Bob Macke. I'm the curator of meteorites at the Vatican Observatory, and I am back once again at the Lunar and Planetary Laboratory at the University of Arizona in Tucson, where I've been working on this pycnometer, which will be used to study the density and the porosity of specimens that have been brought back from the asteroid Bennu by the OSIRIS-REx spacecraft. It's currently returning to the Earth. It'll be arriving in September. We have to get this thing ready to be installed in a glove box in a clean room at NASA Johnson Space Center. As you can see, there's still a lot of work to be done, so let's get started. The specimen to be measured will be inserted into a small chamber mounted to the inside of the glove box, but the operating mechanism will be on the outside. And by the way, for details on how this thing works, please see my previous video on the pycnometer. Anyway, in the original design, the sample chamber is mounted near the wall opposite where the operator will stand. And now I finally got around to making a cardboard mock-up of the glove box with the correct dimensions, and this makes the problem evident. The opposite wall is just too far away to reach or operate the pycnometer. So to deal with that problem, I redesigned the mount to stick in an extra foot. And by the way, this apparatus has to fit through a small hole only 4 inches in diameter. Now to test this arrangement. By the way, I am wearing thick gloves to simulate the loss of manual dexterity when working in the glove box. Okay, this works. Alright, let's move on and build it. So initially all the parts are 3D printed, and this is for prototyping. I'll probably make several tweaks before the whole design is ready. The final design will be made out of aluminum or stainless steel, which are materials that are acceptable for the very sensitive environment inside the clean room and the glove box. I've made the T-bar support in several pieces so they could be printed. The final design will probably be one unit. They snap together, but off screen I'll add bolts to secure them. This is the plate that will mount to the glove box. In the final design it will be solid and airtight with the T-bar mounted on either side, but for now I made it so it could slide onto the T-bar, which is easier to work with in this stage of the design. This is the base of a box that will hold all of the solenoid valves and plumbing components that form the mechanism of the pycnometer, and it'll attach to the T-bar with a few bolts. I tried to hold up the device with these cardboard stands, but you know, they really didn't work very well, and later I 3D printed some more sturdy supports. The next step is to disassemble the pycnometer so that the various parts can be mounted. Let's speed this up a bit. The sample chamber will be screwed to the front of the mount, but the holes need to be opened up a bit so the screws can pass through. 3D printers don't manage design tolerances very well, so the holes are just a hair too small. And since the front end of the prototype can come off, I'll use that to my advantage to make it easier to screw the chamber into place. The valves and plumbing system fits nicely on the base of the box, and off camera I will bolt it into place. This long tube will connect the sample chamber to the valve box through a hole in the big round plate. A few small bends and adjustments will be needed to fit everything together. And before closing off the box, all the gas and electrical fittings need to be reattached. Now let's close off the box. The pieces are designed so that the tubes and other critical components can pass through. For now, I'm leaving this side open. There are a bunch of connections passing through this wall that I still need to work out later. Now for the lid. There is a flow rate control valve that sticks through the top and it gets screwed down tightly to the lid. You might think I'm done, but wait, there's more. This is why we prototype, so that we can find out when things don't quite work right. The specimens will go in a cup like this that slides into the chamber, but when I try to extract it, that steep angle makes it just a little precarious. We don't want to risk dropping the cup and the precious scientific specimen inside. So this calls for a small redesign of the front end. Currently it's at 45 degrees. But we'll change it to 30 degrees. I still want some angle so the operator can see inside the cup from the other end of the glove box. The new piece gets printed on the lab's 3D printer. This printer is a bit different from my own at the Macke makerspace, and it doesn't have a flexible build plate. That means it takes a bit more effort to get the pieces off. So now we'll dismantle the front end so we can substitute the new piece. You can see how the new front end has a shallower angle. So now let's test it. Oh, that's much better. I've also had a rethink about the design of the plumbing box, so let's take the old one apart. That'll also mean removing the plumbing system again. The new box design assumes that the individual pieces will be cut from sheet metal that is then folded into shape, which is how the final box will be made. I've also moved it further away from the round mounting plate. I made a temporary wall for the gas and electrical pass-throughs. This will probably be redesigned several times before the final manufacture. In this new design, the pressure transducer will partially stick out of the wall so the data feed connector can attach on the other side. There are technical reasons to do this that I don't want to get into here. All these changes mean some of the tubing has to be replaced so it all fits. I'll speed through this process. And let's finish assembling the new box. Well, it's starting to look like a thing. There's still a long way to go before we're ready for prime time, but for now we have a structure that I can take to NASA for some exercises that we're going to be doing in March. And that'll give the curation team a chance to examine the device and recommend any further changes that might be necessary in order to incorporate it into their systems. And after that, we'll finalize the design and construct it out of metal. So, time for a few acknowledgments. First, Dr. Andrew Ryan, the lead of the OSIRIS-REx Sample Physical and Thermal Analysis Working Group, has really spearheaded this project and also sourced many of the materials that we've been using on this. And this year, we've got an engineering student, Derek Lee, who has been working on this project especially while I've been away in Rome. And I hope to have another follow-up video later to show some of what he has been working on. Hopefully also at some point I will be able to get some footage of when this thing is finally installed and getting real data. I hope you enjoyed this video. If so, please like and subscribe. The Pycnometer project is sponsored by the OSIRIS-REx mission, but the video itself is done on my own time. And as usual, this video is not sponsored by the Vatican Observatory, although I do use their resources for filming and editing. The purpose of the Vatican Observatory is to be a sign to the world of the compatibility of faith and science, and it can use your support. If you'd like to support the work of the Vatican Observatory, or even just to learn a little bit more about it, there is a link in the description. Thank you. So that's all I have for you today. Until the next video, peace.